Uh, good, uh, Good afternoon, everyone. Welcome to that last session about the logical data warehouse. It's going to be quite a technical presentation. So, to begin with, let's have a look on the concepts of the logical data warehouse and data virtualization and how they are different and what they are. In 2015, Gartner defined the logical data warehouse as a architectural layer that is on top of the physical usual data warehouse and connects to other data sources, whether they are structured or not. It uses the persisting data that you have in your physical data warehouse to mix it with different data sources without having to physically move and store the data anywhere. So what does that mean in a simpler way? So we have a logical layer in red over here that will sit on top of your physical data warehouse. There's no storage in a logical data warehouse, so it will be just querying and transfer the data over the network, but there will be no physical storage of your data. From there, you can connect to different sources. For example, in that case, a web service to get the date of birth and age of your customers. Again, without having to do any ETLing or replication. You can combine that data, joining them together without having to wonder which kind of data it is, or even having to physically move that data again. And you can then transform and process the data how you want. And because it would be a bit useless to have just that layer, it's then exposed to be used by querying tools such as Tableau, Business Objects in our case, any of the usual reporting and analytics tools, or even some applications, direct querying, API, etc. So what's the difference between the logical data warehouse and data virtualization? Well, you can use data virtualization to implement your logical data warehouse. But you can do more than that with data virtualization. You could do, for example, let's say you have a system, transactional system that is using SQL Server, and you want to move it over to Oracle. You can use data virtualization to make your database system agnostic and then just plug it from Oracle to SQL Server seamlessly for your transactional system. So a few words about the logical data warehouse at Landsbankinn. This is our data landscape before the logical data warehouse. We have a pretty standard chain of ETLing from source system to data warehouses. We handle, of course, business data like accounts for customers, loans, deposit, credit cards, etc., as well as more internal systems such as the coffee orders, the scans in and out of the buildings, etc. And this is processed and then this is consumed by reporting systems. That's in a pretty normal chain. So if you have a look at how it was before, it was kind of a mess and easy to track, especially because we had too many query points. Each of our sources were a different and distinct query point with a lot of different technologies and a lot of different source systems, like I said. All the business logics were scattered all around. Every red dot in that schema would be, for example, in that case, in that simplified schema, a place where some business logic is stored. So it was easy to lose track of that. Same thing with access control. We would have a lot of places where you can control the access. So this had to change, obviously. So the idea behind the logical data warehouse is to take all those green dots and purple dots and move them around to create one single repository that is the logical data warehouse in that case. The idea is to create a single point of query Like if you need anything for, if you need data that will be not transactional, if you need to do some analytics, for example, or some data interaction, this is where you would find it in your logical data warehouse. Single point of truth as well. All the business logic is moved into your logical data warehouse. You can use and leverage some lineage capabilities from your data virtualization platform to get the source of that truth. And single point of access control in a way that this is a single point of query, so you can put all of your access control in that. I will talk about that a bit more later. Phase 2 is to add more modern BI analytics tool to get more compatibility with our logical data warehouse. Adding more data sources, like getting data from web services online, getting data from websites such as the Hackstova, National Institute of Statistics. And the third usage would be to close the loop and use the logical data warehouse as a source for the physical data warehouse. We've created a lot of new information that logical data warehouse than the physical data warehouse was interested in. So we closed the loop by doing it in the phase 2. So if you get into the belly of the beast, well, let's say we have like different data sources like that with different types. And you will create some base views and create some data sources, which are basically the connection and how to access your data. And base views, which will be an abstraction of your physical data source. Whether it's files, tables, database tables, and so forth. Then you will combine them together, joining them, union, merge, whatever you want. And once you're ready with them and you want to make them public, you just literally make them public and ready to be accessed for your business. Of course, this is a simplified model. In reality, we have about 1,000 views now in our logical data warehouse and about 200 published views. And all that is structured between the two pillars of administration, governance and management, to get some lineage and impact analysis capabilities, and as well as security management. So where are we with it right now? We have about five distinct data source types, such as Oracle, SQL Server, JSON files, with some REST web services, some SOAP web services, etc. And a total of 15 data sources in our data warehouse, a bit more even now. We have this layer cake of view where we transform that data, and we have connections coming to the data warehouse, logical data warehouse, by 3 different data extraction and querying tools. So a few words about the data security model we've implemented. A small disclaimer. This is just inspired by the truth for confidentiality reasons. Before implementing the logical data warehouse, we had 3 different ways to, 3 different levels of security. Either can you connect to the data warehouse, can you see the objects of your data warehouse, and in those objects, what can you see? So it led to some issues. Let's say we have the same team refreshing the same business objects document. The 4 of them would have different results because they were not aware of their security, and they could lead to some serious decision-making problems. So we changed that. We chose to redesign that for obvious reasons after what I mentioned. And we've met with a lot of IT departments. We're actually even doing it again now for the phase 2. And we redesigned the entire security model. So it's still managed by the Active Directory through ID groups that based on the roles and the organizational level. We do mask some data, so all the personally identifiable information of the customers you're not supposed to see in the system, or data you're not supposed to see. in general. And we've developed also a system to help users know which accesses they have and how they can ask for more if they need to contact anyone. And of course, on top of that, we have some monitoring and alerters on unusual connections. So that means that we have now a system like that where the person with the most access will see a dataset and everything in that dataset, and someone who will be more restricted will see the same data but without personally identifiable information, etc., etc., etc. But the content, the important content of the dataset is still there. So I will go a bit technical here. How has it been implemented in our logical data warehouse? In our data virtualization platform, you can create roles mapped to AD groups. And each of those roles contain filtering and masking capabilities and rules. Let's say we have a customer representative, so he is mapped to the same role. And in that role, we define that if you query the table customers, you will apply some filtering. Say, OK, I don't want to see the people living in the east. I don't want to see you're not supposed to see the people living in the north, or and then just mask the personally identifiable information for those people. So from there, it's a system quite similar to the to Oracle Virtual Private Database system, where in the end the query you send to the system is not the one that will be executed, because you will have some behind-the-scene filtering and masking applied to mask your data. And as much as possible, your data virtualization platform should be able to push down that query, that modified query to the original database, so that your logical data warehouse don't handle most of the calculations. Another usage of our logical data warehouse is to use it to extract data beyond just simple reporting. So we've chosen Denodo as a data virtualization platform in our case. So we're able to use this product called the data catalog, where end users can search for data literally. And from there, they can just click on a button and export this dataset to, say, Excel, for example, Tableau, or whatever. And we've also created a set of web services based on those views in the logical data warehouse platform itself, where we expose the content of some views as REST web services. So in a way, we give the opportunity to users to get the data directly from any tool that supports web services querying. What we want users to have next, what we wish they can have next, all those data web services should be moved to the source systems directly. For example, CRM system could be calling these web services and display those lists directly there instead of having to go through another tool. And we would like to have some experts in each department to create their own content in the data catalog. So this is in a near future. Next usage, to close the loop, like I said earlier, our data warehouse is always hungry. So we like to give him more data to feed on. So yeah, let's see how we leverage the logical data warehouse to do that. Let's say we have an ETL system that cannot connect to web services, for example, or for some reason is limited because of some licenses. And we need to get data from external source systems. Let's say we need to connect to the National Institute of Statistics to get the inflation for the last 2 years or something. So in that case, the ETL couldn't leverage that kind of thing. because it cannot connect to web services. Um, and you could also use that system to connect to outsourced system through the web, for example, some software as a service platforms. Let's get an example. We have our HR system that is as a software as a service platform. This HR system exposes data as a SOAP web services. So we can use our logical data warehouse to connect to that SOAP web service and extract the data we need, such as the username of the person when he's been hired, their personal details, and so forth. The problem is this system is not historical. We only have the status as it is today. So if we need to store it like every day to be able to do some analysis and to create a type 2 dimension, we need to physically store it. And this is where we use data virtualization for that. So we connect to this web service through our internet, and we flatten and structure that data source to store physically that data into our data warehouse in a specific schema. From there, our ETL tool gets that data, processes it, transforms it how it should, inserts it in the physical data warehouse, and then from the physical data warehouse, it's consumed again by the logical data warehouse as a type 2 dimension, and it can be used from reporting platforms. So as you can see, you can use the logical data warehouse and data virtualization for a lot of different usages. I feel like I've only covered maybe half of how we're using it. So yeah, just be curious about it and enjoy your day.